Okay, let's get started with lecture number 2, and this is continuing our discussion from lecture number 1, and we're continuing to look at manufacturing process choice. So how do we find the right process for the part or product we want to manufacture? All right, that's really the basic question right there. How do we find the right process? This is the most complex issue of product design. Right, so we could make all the sketches that we want, neat sketches and really cool ideas, but unless we can figure out a way how to make it and make it efficiently and make it effectively and make it so that it functions properly, all we have is a bunch of pretty pictures. This affects how the product looks, feels, how much it will cost, and whether it can function as intended. Those are 4 of the largest, biggest, most important factors, and they're all linked to finding the right process to manufacture our parts. So this is a very detailed decision, right? It involves material variations, process options, processing parameters. It's a multifaceted optimization problem. There's that word again, optimization. Again, there's too many variables, so what we have to do is optimize it. We have to figure out what's the most important and kind of drive towards solution with that and hope that everything else kind of follows along and evaluate iteratively the whole time so that we can make sure we're not making a bad decision or we're affecting something upstream or downstream. Often there's not a clear best choice. And systematic points to guide the decision-making process include how to choose the process and when to choose the process. Okay. So we already talked about this at the beginning of lecture number 1, but product design process consists of several consecutive phases. We looked at it in the first lecture from the point of view of what decisions need to be made, but now we'll kind of look at it from a more basic framework. So the first thing is the fuzzy front end. What is the fuzzy front end? Well, that's where we're coming up with ideas, right? We're tasked with designing or solving this problem, and so this is where we're generating ideas, coming up with potential solutions or wild harebrained ideas. Once we exit the fuzzy front end, we come into conceptual design. This is where we start to make things a little bit more concrete, right? So we start to get a better feel for how we're going to achieve our design objectives. The third step here is the actual design engineering. So at this point, at the third step, we have an idea or we have a design that we think we're going to go with. Now, there's still feedback here. So, things could change depending if we reach a roadblock or, something crops up that we didn't count on before. But generally speaking, now at the design engineering stage, we're actually designing the product, okay? Working out all the bells and whistles and details here. And then finally, the last is the detailed design. This is where we're going with this design. We need to figure out how we're going to manufacture it and what everything that goes into that entails. Okay, so we can break this up into 4 phases. Phase 1, fuzzy front end. Phase 2 is the conceptual design phase. Phase 3 is the design engineering phase, and phase 4 is the detailed design phase. I do want to say that if you Google product design process or engineering design process, you will probably get 1,000 different ideas, solutions, flowcharts. So this is not the one end-all be-all production design process. This is a general one that doesn't have a lot of phases, doesn't have a lot of steps, only 4 phases in this. But it still talks about all of them are going to have basically the same fundamental components or pieces here. And again, just to reiterate, every phase involves iteration and feedback. Okay, so let's look at what happens in each one of these phases. So in phase number 1, the fuzzy front end, this is where we have a problem and we have to find a solution to it. Okay, so the design process kind of emerges organically, right? From this point, there's a lot of talking and a lot of thinking and a lot of sketching of ideas. The company may hire an external design agency to handle this design. They could join with other companies to explore a new design, or they can decide to transform a new technology into an existing product. The output of this phase, that is what we want at the end of phase number 1, is clear specifications of requirements for the product to be designed. What do we want the product to do, and how do we want it to do that? So our goal is the design problem definition. Phase number 2 is the conceptual design phase, and this is where the initial design solutions are conceived and explored. Okay, so we take what we get from step number 1 and we push it forward. So do we want to redesign a product? All right. Do we want to take a product and improve upon it, add different features, make different sizes, whatever? So we can work on the existing product working principle and the general layout, take the normal design, and then redesign it. The other option is to produce a radical design, a new design, something that hasn't been seen before. So in this case, before we had robotic vacuum cleaners, the idea of a Roomba was radical. What? You're going to design a robot that goes around and cleans the floor automatically? So this would be what we would call a new design. So we could have redesigns or new designs. So the design concept then is a design proposal that will actually work, and can be produced at an acceptable cost. Okay, so here we're not wild-eyed brainstorming anymore. Now we're really trying to come up with something that's going to work and that we can produce at a reasonable cost. So there's a lot of factors that go into that decision, and we're still a bit above the actual detailed production here. But the analysis is going to be broad, but not deep. Okay, not deep. We're not going deep yet. We choose the most promising concept from a range of options. And then that's what we go forward with to phase 3, design engineering. This is where the chosen design concept is elaborated and optimized. So from phase 1, we have our, hey, this is the thing that we're going with. Phase number 3 is to iron that out, okay? To elaborate on it and optimize it, to make it workable. So at this stage, the analysis gets narrower and deeper. This can include CAD and CAE, computer aided engineering. This is your simulation, your animations, your kinematics, all that kind of stuff. Prototyping basically means making test parts or test assemblies to see how everything functions. Validation studies and testing. Our goal here is to eliminate or minimize risks, right? So we want to do all this testing, all this prototyping, all this computer simulation so that we're not bitten later on down the road with something that isn't going to work, that we should have found out earlier. Okay. So then we move on to step number 4. Step number 4 is the last step before we get into production, and that is the detailed design. So this is where the whole design is fully detailed and documented. This is where you produce your drawings. This is where you produce your manufacturing plan, your production plan. This is where you start to formulate your marketing plan, how you're going to sell this, how you're going to market it. Any changes at this point should be related to manufacturing and marketing. All right, and they should be small. Any large changes at this point, and that's problematic. All right. In normal design, that is, when you're redesigning something, manufacturing and marketing are planned much earlier. All right, so now moving on to manufacturing choice. It's considered gradually and iteratively. Okay, so we first want to start considering our manufacturing options in phase 2, right? The conceptual design phase. So phase 1, we're not really worried about manufacturing. Maybe it pops up here and there, but really phase 2 is where we're going to start to consider what our options are for manufacturing. So for metals, we're talking about casting, forming, extrusion, forging, machining, and additive manufacturing. For plastics, we're talking about injection molding, thermoforming, resin transfer molding, and additive manufacturing. Okay, so notice it really breaks down into the first question you have to ask yourself as a designer or a design team is, are we going to make it out of metal or are we going to make it out of plastic? Okay, so that's really the first fork in the road, is the metals or plastics fork. Okay, so remember from a couple slides ago, normal design decisions, this is a redesign. This is something that we're, it's not revolutionary. Decisions may be carried over from previous designs. Radical designs, everything is on the table, right? We're designing something that's never been seen before. We have, let's just figure it out from scratch. And as I said, the first question that we really have to answer is, are we going to make it out of plastic or metal, or something else, right? But plastic or metal. So remember our talk about the manufacturing hierarchy, right? Principle, method, and equipment, right? We start up at the 30,000 foot level of principle. We come down a little bit lower to the method, and then we get down to ground level, and that's the actual equipment that we have on hand to produce the part. Where each of those manufacturing processes or principles, I should say, comes into play with our design process now. So in the conceptual design phase, right, phase 2, we're going to be focusing mostly on principle, right? That's really all we have to go with. We don't have the solution or the design framed out enough so that we can start to get into method, and certainly not equipment. Maybe a little bit of method creeps in there. Once we move on to phase 3, design engineering, now, okay, the principle has already been decided, so now we have to start moving into the method. So what is the exact method that we're going to be using? And here, a little bit of equipment can maybe creep in. But when we get into phase number 4, our final phase, this is where, okay, we got to focus on the equipment, exactly how we're going to produce it, where and when. So this manufacturing choice is done in a stepwise manner. Okay, there's different steps to it. From the general, from phase 2, to specific and detailed to phase 4. So it goes something like this. First, we want to figure out what material we want to do. Is it metal, plastic? Is it other? Then after we figure out that, which manufacturing principle are we going to follow or are we going to use? Then what's the manufacturing method? And finally, what specific manufacturing equipment are we going to use to produce this? So it may look something like this. Hey, we're going to use metal. All right. And then we ask ourselves, what type of metal? Well, aluminum alloy. Okay. What type of aluminum alloy? Well, a 5000 or 6000 series. Okay, specifically what type of aluminum 5000 series? Well, the 5054H2 or the 5054H4. Okay, so each step here, we're going from general to very specific. And each step is going to give us a more concrete look at the properties associated with that and the manufacturability and all the things that we need to know for phase 4, the detailed design. So this is kind of a graphic that helps us to understand the different materials that we have, the menu of engineering materials, so to speak. So at the top we have metals, right? Steels, cast irons, aluminum, copper, zinc, titanium. Obviously there's others. This is not an exhaustive list. Then we have on the going clockwise, we have the polymers, the plastics, right? Polyethylene, polypropylene, um, uh, uh, all the different polyesters, phenolics, epoxies, all that good stuff, nylons. Continuing down here, we have the elastomers or the rubbers, then glasses, ceramics, and then in the middle, we have hybrids. This is where we get to join these different major materials together to make these hybrids. Okay, so this can help you kind of understand what the menu is. This is not an exhaustive list, by the way. All right, so let's go back to our manufacturing triangle, right? Remember this, the different attributes. We have quality, function, and cost attributes, and then the sub-attributes for each one of these, the function sub-attributes, the cost sub-attributes, and the quality sub-attributes. All of these play a role in helping us to determine the manufacturing process. So there's mutual dependencies in a lot of these. So for example, part shape and materials are mutually dependent with the manufacturing process. So we have to be mindful that these have they're kind of woven or linked together. These, in fact, are your manufacturing process choice main drivers. All right. What is the material? All right. Obviously, the material, plastic or metal or other, is going to, be the first fork in the road right there. Part shape is it a very complex part shape? Is it a simple part shape? Is it, kind of two-dimensional, or is it a complex three-dimensional? Does it have hollows? That determines a lot of whether it can be cast or forged or machined or all that good stuff. Production volume is also is often a decisive factor for process choice. Okay, so how many parts are we going to make? Are we making 10 parts, or are we making 10,000 parts or 10 million parts? Okay, think about it from the point of view of an automobile. If you were only making one automobile, that automobile would be very expensive, right? If you're making tens of thousands of these cars, well, then it starts to get cheaper and cheaper. Part size is also important, right? Large parts require special production processes, right? Small parts also have special production processes. Now, in the next few